All right, second day of quadratics. Focus will be graphing, all right? So basically I have 4 graphs I want to take you through, but to get started, we take a slightly different approach to producing a graph of a quadratic depending on what form it's in, okay? Let's get those out there right now. Standard, I'm pretty sure we talked about in day 1. In fact, I know we did. ax squared plus bx plus c. Vertex, which I don't think we've addressed yet, looks like that. And factored, which at some point you've seen looks like that. Yeah, it looks like, really for the most part on day 1, it was all standard, okay? So here's what we'll do. We'll kind of focus on each one, and I'll take you through, kind of how this looks and how it works. Each one has 3 parts, okay? So if you are talking standard form, number 1, kind of goes without saying that when I say like find the point, the reason you want to find it is to graph it, right? So find / graph. The vertex, okay? Now the coordinates of that point would be negative b over 2a. And then this, if we're saying that this is f of x, right, a function named f, it's f of negative b over 2a. All right, that's just function notation for saying if you want the y value, you got to go plug it back in, okay? Second thing, graph the axis of symmetry. That's just the x-coordinate. It's a vertical line that goes right down the middle of a quadratic, okay? Graph the y-intercept, okay, which is in standard form, x is 0, and the y value is c. And this, I might need to show you an example, and then reflect that point to the other side. Okay, and you would graph that point as well, okay? We do the y-intercept, and then go ahead and reflect it. So 1, 2, 3. Okay. Again, now that might leave a few questions. We'll get to it. All right. Well, you'll see all three of these in action. All right. If you're in vertex form, you should notice some really strong similarities here. Graph the vertex. Now, as the name suggests, it's pretty accessible to find. You don't even have to look for it. It's right there. HK is the vertex. Okay. So you got that. Number 2, no surprises here. Graph the axis of symmetry. Which again, here in vertex form, you don't even need to do the negative b over 2a, right? You don't have those coefficients b and c. It's just h, right? X equals h is the vertical line that gives it symmetry. Same thing, find the y-intercept and reflect it to get another point. So what I want you to see in vertex form is basically the 3 things we'll do are the same, right, as standard. We just get them a little bit differently because the equation is written in a slightly different form, okay? Now, one thing right here with the y-intercept, K, that's not the same thing as C, okay? So if you're like, oh, it's just 0, I mean, to get your y-intercept, right, just plug in 0 and see what you get. You more than likely won't get K. So just because it's a constant at the end, don't just assume that that's the y-intercept, because it very rarely is. Okay, that's why when we like define the formulas with their parameters, like A, B, C, H, K, I know it gets kind of confusing with all those letters, but different letters mean different things, right? C, the constant that ends standard form, is not the same thing as K. K is the y-coordinate of the vertex, not the y-intercept. If you just remember to plug in 0 for x, you'll be good. All right, so this last one is a little bit different, okay? Little bit different. If you're in factored form, what you have that's pretty accessible, right? Because let me just add this before we get into how we do this. P and Q are the x-intercepts. That's actually something we covered a little bit in the first day, that if you take a quadratic and you do put it in factored form, right, what we would call the x-intercepts or the zeros, they're pretty easy to find those. In standard and vertex form, it wasn't so bad for us to find the vertex, which we can find here as well. But we're going to use the two x-intercepts, and the other two we didn't, because that's what we have, right? That's the first part, find and graph the x-intercepts, right? And again, they're really, really easily available, right? Now, here's the thing. You could have, to find these, you might need to solve a little bit, right? I'm kind of setting this up that I'm saying that, you know, A is just out front and there's no number with these x's in here. That could change, okay? Just don't forget, if you need to find them, just set the factors equal to 0 and solve. Okay. If there's a number in there with x, right? Go off of those notes you have from day one. That, all right, you set each factor equal to 0, solve it, you'll have your x-intercepts, okay? So the one I'll show you, it's pretty simple. There might be a little bit more going on, right? I can show you one of those in time. But just, you'd find the x-intercepts the same way, okay? All right, number 2, we'll find and graph the vertex. We'll go about it a little bit differently. Once you have both x-intercepts, just take the average, okay? Take the average, right? And then whenever that number is, plug that in to get the y value, right? But we wouldn't do the negative b over 2a thing because we don't have b, right? But the vertex is going to be halfway in between the x-intercepts. Okay, so just take the average and then plug that in to get your y value, and then label axis of symmetry. Okay. Now that's all great. Those are a lot of lovely ideas, but you're probably thinking like, holy cow, like for this to make sense, I need to see some of these ideas in action. Okay. which right along with these definitions of how you do it, we'll make sure you have at least one example of each of these. Starting with standard form, okay? So I'll just go in order because I labeled them, okay? So number 1 in standard form was I got to find the vertex, okay? Now, by the way, you don't need to write this out, but just for the sake of having it, A is 1, B is -6, C is 10, okay? So you would have 6 over okay? And now remember, you got to find f of 3, which that would be 9 minus 6 times 3 plus 10, which would equal 1, okay? Now the big thing that tells me is the vertex is at 3, 1, okay? Now, once I have that, axis of symmetry is a breeze, right? It's x equals 3. Last but not least, right, the y-intercept I know is 0, 10. Okay, now I'll reflect that point here in a minute. I'm going to make the graph next. Okay, so here it is. But everything I know, there's 3, 1. Okay. Axis of symmetry, and this quadratic is a mirror image on both sides, goes right through there. Okay. Y-intercept is way up here, right? And I can tell from the equation this opens up, right? So here's what I mean by reflect. It's 3 units to get over to the axis of symmetry. Go 3 over on the other side. And you would see the point 610. So I'm going to scoot back over here real quick. That's what I mean by reflected. Because I use the fact the graph has symmetry, I know 610 has to be a solution as well. And once you have those 3 points, you can kind of see it. This is going to go up like that and go through there. And then the same thing right there. And there's your vertex, right? And again, that was starting from standard form. Okay? But now you got each of those three steps. Now here's the next one. Same thing, we'll break down the 3 steps. I'd probably say this is the best form to graph, quite honestly. It's a vertex form, if you hadn't figured that out. You can go ahead and label those. If you want to go back to the first one and say, hey, it was standard, right? Because I gave you that kind of outline with each of those parts. Let's actually do that. Let me go back up here. That wouldn't be a requirement on like a quiz or a test question to like label which form it's in, but you know, with the notes you have, that should be where you start. Like, okay, what form am I in? Okay, this is vertex, which is a good thing because that means right off the bat, oh, I need to find the vertex. There's nothing to calculate. There's nothing to find. I look at it and I can see it's at -3, 4, which means the axis of symmetry is right at -3, right? That's really nice. No negative b over 2a, no having to plug that in to get the y value for the vertex. It's all just right there, okay? Remember, this part I have to be a little bit more careful. You know, I'm getting my y-intercept. It's 0, right? Tempting to say that the y value is just 4, right? Don't do that. Stick with plugging in 0. Once you do that, you see, hey, wait a minute. It's negative 14, which is going to push us off our graph a little bit, but that's okay. We'll deal with that. Let's get the first two parts, right? Negative 3, 4. There's the vertex. Here's the axis of symmetry, which I like to label on the graph. It's a vertical line that goes right down the middle of it. Okay? And now 0, I got to go down to 1, 2, 3, 4. I'm off grid. Literally living off grid. But here's the thing. I got to reflect it to get this other point. It's going to have the same y value when I reflect the y-intercept. It's 3 units over to the axis of symmetry, so I'm going to go 3 more. And then just put right here at that point, right, which is 4, negative 6, negative 14. But then once you have those 3, it's a little funky that I'm going off the graph here, but it opens down. Kind of missed that point a little bit, but that's okay. Good enough, right? Not a great sketch, but it's just a sketch. It's not going to be perfect, right? I got where the vertex is, axis of symmetry. It's kind of a longer, skinnier quadratic because A is negative 2, and it opens down. So even though it's not the best sketch in the world, as far as what I want to tell about this graph, I can, okay? All right, as you might have imagined, consistent with the same order that we did our list, here is one that's in factored form, right? And now that you've seen those first two, know that here, we're going with the same approach that, like, I want to get the vertex, and then if I can get, like, 1 point on either side, it's enough to kind of tell the general shape and the direction of the quadratic, okay? Now, this is that nice case where those, like, you have P and Q, right? Now, to get those, just, you know, if you want a little bit of insight, as always, I could take each factor and then solve it. I just did it in my head because the math here is really, really simple, but that's how you would do it, right? If there were some numbers in front of these values of A right here, kind of like values of A. And if it was like 3x plus 4 or 5x minus 2, just solve it. You'll end up getting fraction answers is all it really means, okay? Not a big deal. But I've got both of those. We also want the vertex, but this is where it gets a little interesting, is you literally just average your 2x intercepts, right? By the way, if I jump down to part 3, that's my axis of symmetry. Done. Okay. I still got to plug this in because I need an x coordinate for my vertex. Plug in negative 1 there. Plug it in there. Should get negative 4.5, right? Oops. Which would mean for my vertex, would be that. Notice again here the y-intercept I don't find, and when we graph it here, I'll show you why. I like to start with the vertex, negative 1, negative 4.5. It's going to be right down there. There's the axis of symmetry right at negative 1. Okay? But I also knew this, that negative 4 and 2 Try to make those nice and big so you can see them. There's the vertex right down there, right? The whole purpose of like the y-intercept and reflecting the point across the axis was to get like these 2 points that were in the direction of which way the quadratic opens. When I'm in factored form and I use the x-intercepts, I don't need to do that because I already have it. You know, you can see they're both exactly 3 units away because the quadratic has symmetry. But from the vertex, I could go up and say, okay, go right through that x-intercept. And then here, do the same thing, okay? You can kind of get a general guess of where the y-intercept would be, but again, don't need it. Because that's on all of these, like with the 3 steps, it's like, all right, where's the vertex? And then give me like 1 point on either side of the axis of symmetry, and I'm good to go. And I can tell you pretty accurately what this quadratic, what its graph is going to look like, right? Okay, last one. Looks as though we're back to standard. Last one of the day. So at the end of the day, you've got those notes for like the 3 things you have to include. You've got 1 example for vertex, 1 for factored, and we'll have a second one for standard, okay? All right, negative b over 2a is 2 f of 2 is 5. Right? Remember, in standard form, that is very, very first thing, get that vertex. Second thing is always a breeze. Axis of symmetry is at x equals 2. Third thing, right, this is back to standard, so that value of c at the end, -7, that is the y-intercept. And again, as far as the point that I'm going to reflect, I like to start my graph first, and it's almost like I'll get to that in a minute. Okay, not yet. So here's 2, 5. Right there. There's my axis of symmetry, right at x equals 2. And the y-intercept was all the way down here at -7. Right? You can tell it's another one of those that opens down. All right, in fact, like I could already draw in this half of it and say, all right, going down that way. And I got 2 units, right, over to the axis of symmetry. So I go 2 more and just reflect it over. And then can tell you it looks like 4, -7. And that's okay to do that. You know, if you want to go start to make your graph to get that other point. Because once I have it, I sketch a exact copy of what I just did over on the other side. And there it is. All right, again, you're pretty well equipped here with your notes as far as what you'd be asked to do on graphing. Factored, standard, vertex, you've got exactly what to do for each. Remember, 1, 2, 3, right? Each of them have 3 parts, and you've got examples of what each of those 3 parts look like. Just to look ahead to day 3, we're going to write equations. So we wouldn't, graphing will be the focus in day 2, but then in day 3, it'll be like, hey, here's a little information about like a problem that could be solved with a quadratic. We're going to write the equation, whether it be standard, factored, or vertex.